All right, thank you so much for joining us today. And this is our first video on derivatives, and we are going to talk about limit definition. I have videos on limit too, so you can have some time, you can get some time and go and watch them out. Now let's start. Now with derivative, we will use something like y prime. We can talk about dy over dx, and we are going to talk about f prime. Yeah, they are all something that we are going to use throughout this journey on derivatives. But let's talk about limit, right? So what's the limit definition? It's very simple. F prime is equal to limit as h is approaching 0, f of x plus h minus f of x divided by h. This is the limit definition. Some people call it the first principle. So it's the same thing. So now that we know the limit definition, let's take some example and then see how to go with limit definition with different type of function. So I'm going to talk about polynomial function, rational function, radical function, and trig function in this video. Then I'll give you some prior question to also do as well, and we'll see how we are going to evaluate them when a specific function is given. So let me now start. Now we know this is the limit definition. Let me now start with this. This is a polynomial function. So let's see how we can go through a polynomial function. Let's do that. So using the limit definition, it means that when I differentiate this one direct, I'm not getting anything for it. But what we need to do is, since we are talking about limit definition, it means that we are differentiating the function. So if I know how to do the differentiation, I'll just differentiate it and put it down. So I'll talk about how to do that, but I'll just do it without explaining. So this is going to give us 4x minus 7. So when I differentiate this, this is what I'm going to get. So this is f prime. F prime, right? So using the limit definition, it means that this is the result that I need to get at the end of my solution. If I'm not getting it, then this one is telling me that I've made some mistake somewhere. So now let's go through the limit definition. Now I know that the limit definition f prime of x is equal to limit h is approaching 0, f of x plus h minus f of x divided by h. It's always, a question is given to you, they are going to give you f of x, right? So since they've given us f of x here, so 2x squared minus 7x plus 5. Now this is what I do, to help those now, they are not good with, expanding and those things. So I write the f of x again, but since x is in parentheses here, I make sure that I put all my x in the function 2 in what? Parentheses. So I'm going to have something like 2, I put my x inside a parenthesis squared, minus 7, I put my x into parentheses plus 5. Now doing this will help us to find this. Now we know f of x. We need f of x plus h. So how do we find f of x plus h? F of x plus h is equal to, I'm putting this one into parentheses because of this now will help us to find this. So what I'm going to do is, now I can tell you that change all those in parentheses to x plus h, and that's all. So that's the reason why we just did this. So this one is going to be 2x plus h squared minus 7x plus h squared plus h. So as soon as you put all the x's into parentheses, changing them from x to x plus h is not difficult. Now s plus h, s plus h, s plus h. As you can see, x, 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 the same function. So now let's try and simplify, and then we just solve it out. So simplifying this is the same as x plus h, because it is what? X plus h squared minus 7x minus 7h plus 5. Now let's expand this. This is x squared plus xh plus xh plus x squared. So just expand this one, getting that minus 7x minus 7h plus 5. 2, let me simplify the one in the bracket. This and this are the same, so it's going to give us plus 2xh plus h squared minus 7 minus h plus 5. Multiplied through by 2, we are going to have 2x squared plus 4x plus 2h squared minus 7x minus 7h plus 5. Can we simplify them? No. Good. So we are now having f of x plus h2. Now look at the formula. I don't want to come and substitute the whole of this here minus the whole of this. So since the top is looking for f of x plus h minus f of x, I'll solve that one and simplify before now I use the function. So now I'll look for f of x plus h minus f of x, because this is what we are looking for on the top here. So let's do the simplification so that we can just go and put it there. Now this is equal to the whole of that. So let me write it. 2x squared plus 4x h plus 2h squared minus 7x minus 4h plus 5 minus f of x. What is f of x? F of x is here. So minus 2x squared minus 7x plus 5. So now let's try and simplify, and then we move the results in there. So 4x plus 2h squared minus 7x minus hx plus 5, subtract plus 5 minus 2x squared plus 7x minus 5. So you see that the magic will happen. Minus 5 cancel 5, 7x cancel 7x, minus 2x squared cancel this, and it will be left with 4xh plus 2h squared minus 7h. Anytime, one trick that you need to remember, anytime you finish f of x plus h minus f of x, your terms here, all of them should be having h. So you see that this is h, h, h. You should be having h inside, and then all the term without h should be going away. So you see that this is having no h, this is having no h. This the ones without h will just go away. Then since all of them are having h, I can factor h out. So this one will be left with 4x plus this one will be left with 2h minus 7. Good. So this is equal to this. So everything on the top here is equal to what I have here. So now let me continue from here. So now I can write my limit as limit h is approaching 0. Then the top is now h 4x is it minus 2 or plus 2? Plus 2h plus 2h minus 7. Then divided by the h. So divided by this h here. So the top we simplify and have gotten this. And then when you do that, the magic will happen. And then we are going to now have limit h is approaching 0, 4x plus 2h minus 7. We did this because of we cannot plug in 0, because when you plug in 0, this is 0, and we cannot do that. So now that we are not dividing it by h, we can set h to 0 and then just do direct substitution. So this is going to give us 4x plus 2 times 0 minus 7, and this is going to give us 4x minus 7. You see that this is the same as that, confirming that indeed we've used the limit definition right. So this is how we solve, or we do limit definition using a polynomial function. So this is a polynomial function. Let's take another example which talks about different function. Example, rational function. So when I have a rational function, how am I going to go through the process? So let's see how we can work with a rational function. So we know the limit definition. Let's write it down. H is approaching 0. That is f prime of x. H is approaching 0. F of x plus h minus f of x divided by that. So don't forget, when I finish, I will give you a trial question to do. So stay here and let's learn together. So now this is going to give us, we have f of x is equal to 1 divided by x minus h. So as I said, for you to find f of x plus h, if you are not good, what you need to do is make sure, since this x is in parentheses, you put all the x's in parentheses. So this is going to be 1 divided by, put my x in parentheses minus that. Then this helps me to find f of x plus h. So I change all the 1 in the parentheses to x plus h. So now I have 1 divided by x plus h minus 7. This is very nice. So now I have this guy here. I have this also guy. So what I need to do is now I'm going to find what is on the top as we did for the polynomial function. But it's just this is different function. So f of x plus h minus f of x is going to be 1 divided by x plus h minus 7 minus f of x is here. So this is going to be 1 divided by x minus 7. Good. Now, this is kind of, I love it because I have a way of doing this. I call it my diagram. So you can use my diagram to do all your fractions like this. So if you remember this diagram, I call this one first, I call this one second, and I call that here third. So this helps me to do all my fraction without using calculator, right? So that if I have something like this, I can't use calculator. So I just need to use my diagram. So my diagram says that go this first. So multiply this to this first. So that's why we have it this way. So 1 times x minus 7 is that. Then minus, because I have the minus here. Then go this 1 second. So I'm going here second. So I'll put it into parentheses because this is minus here. So now this times this is going to give us x plus 8 minus 7. Then divided by, so divided by third is this. So we go this way. So I just multiply this one by that. I'm not going to simplify. So I'm going to have x minus 7 and then x plus h minus 7. So this is what I'm going to get. So is it that it's very simple to go with my diagram. So x minus 7 multiplied through by minus, we are going to have minus minus x minus h plus 7 divided by x minus 7, then x plus h minus 7. Let's simplify. This guy will cancel this guy will cancel this guy. So now it will be left with minus h divided by x minus 7, then x plus 8 minus 7. So we are done. Here, x is standing alone. Sorry, 8 is standing alone. So now we can now come back to the formula that we have here. So now our limit will be equal to, this will be equal to limit 8 is approaching 0. The top here we had this. That's what we had, this one here. So let me write it there. So we had minus 7 divided by x minus 7 times x plus 8 minus 7 plus 8 minus 7. So the whole of this is just the top. So we are going to divide this one by h. So instead of doing it divided by, instead of doing divided by h, I'm going to do it divided by h. Good. So now this can be written as limit h is approaching 0 minus 8 divided by x minus 7, x plus 8 minus 7, and then this one now changes to 1 over h, and then this one will cancel that. So you know where we were heading towards. So this is limit h is approaching 0. So this one is going to be minus 1 divided by x minus h, x plus h. So now the h which was worrying us is gone, so we can set h to 0, and then we just do substitution. So this is going to give us minus 1 divided by x minus 7, and then x plus 0 minus 7, and this is going to give us 1 divided by x minus 7, x minus 7, and this is going to give us, there is minus, this is going to give us minus 1 divided by x minus 7 squared. Good. So this is how you can go through the process when you have a rational function, basically take your time and do it. So this one, when I do the direct derivative, I write this one as this. You understand it very soon. And when I differentiate, I'm going to have minus 1 divided by x minus 7 all squared, which is the same thing as what we did here. Right? Don't worry about doing the straight derivative. We will learn derivative very soon, doing it straight. Let's take another function. Another function is radical function, right? You see that I'm very good. I take different functions and we work together so that you'll be good with all the functions. So anytime you are dealing with limit definition, no fears, because you've worked with all functions before. So same idea, let's define the limit definition. H is approaching 0, f of x plus h minus f of x divided by h. So we have f of x is equal to square root of x minus 5. So as I said, put all my x into parentheses. It helps you to not forgetting, some stuff. So what is f of x plus h? So I'm changing all the x to f of x plus h. So this is going to be square root of x plus h minus 5. This is nice, right? Good. Then I need the one on the top here. So let's look for that. F of x plus h minus f of x is equal to square root of x plus h minus 5 minus square root of x minus 5. So let's try and simplify. This is the same as square root of x plus h minus 5 minus square root of x plus 5. So I multiply 2 by minus, and then this guy cancel this guy. So it will be left with square root of x plus h minus square root of x. But you see that when I move this guy up here, this is what I'm going to get. So let me bring the top there. So now it means that now our limit is going to be like this. F prime of x is going to be limit x is approaching h is approaching 0. The top now will be square root of x plus h minus square root of x divided by h. So I have the h there. I cannot cancel. So remember, anytime you are dealing with limit and it involves with radicals, what do we need to do? We need to do the conjugate, right? Before we do direct substitution. So now let's find the conjugate. This is, I'll multiply this one by square root of x plus h, then the sign changes to plus, divided by square root of x plus h. I change this one to be plus. So what am I going to get? This is going to be limit h is approaching 0. So as I said, anytime you are dealing with conjugate, don't multiply the one which is not having root at the other side. Just multiply the one that have root here and root here. So when I do that, since this is conjugate, I will just multiply this one to this, and then this one to this, then I'm done. So I'm going to have this times this is going to give us x plus h, then minus, because this times this is going to give us minus x. So minus x divided by h times square root of x plus h plus root of x. Now, why did I do this? Because when I multiply this one by this, I have this. When I multiply this one by this, I'll have the positive. And when I multiply this one by this, I'll have the negative. So it will just cancel out. So I just need to multiply this by this, and then also multiply minus of this by minus of that, and have this. Now, one magic will happen here, and then it is going to be left with limit h is approaching 0, h divided by h, square root of x plus h plus square root of x. Now another magic. Now the x that is worrying, h that is worrying us is gone. So we have x plus h plus this. Set h 0 and plug it in. We are going to have 1 divided by x plus 0 plus square root of x. This 1 over 2 square root of x plus square root of x, and this is going to give us 1 divided by 2 square root of x. Good. So this is what I'm going to get. So this is how we deal with radical functions too. Let's take trig function. So we've done polynomial, we've done rational, we've done radical, right? Let's take one function with trig functions, right? So same idea, but here you need to understand trig properties, because we are going to use trig property here. It's very useful. So h is approaching 0, then we have f of x plus h minus f of x divided by h, and then we are going to now have f of x is equal to sine x. So as I said, put your x in parentheses, so I'll put the x in parentheses like this. This now helps me to find f of x plus h. So this one will be sine f of x plus h. So f of x plus h, f of x plus h, the same thing here. Then now I need this guy. So let me try and solve that one. So I need f of x plus h minus f of x, which is the same as sine x plus h minus sine x. But you see that if you just substitute this one inside, it's very difficult for you to do that. So what I'm going to do is I'm going to actually simplify this guy here. You remember trig, where we said sine a plus b is equal to sine a cos b plus cos a sine b. Remember this, right? So it means that we can use that one too, that idea, to expand this. So this one will be sine x cos h plus cos s sine h. So this is what we need to use to simplify. So simplify that, it means that my h is now equal to this. So I can write this one as sine x cos h cos s sine h minus f of x. F of x is sine x. So we do have sine x. Now I'm just going to do something small here. I group like terms. I have sine and I have this one here. So I will just combine them together and have sine x cos h minus sine x plus cos x sine h, and then this is factor sine x out. This one will be cos x cos h minus 1, and then plus cos s sine h. So I'm just now going to put this one up here. So let's do that. I'm going to have something like f prime of x is going to be limit h is approaching 0, then the top is this, which is equal to that. So I'm going to have limit sine this cos h minus 1, and then I'm going to have plus cos s sine sine h, all divided by h. Now what we need to think about here is we need to think about the properties of limit again. Remember the properties of limit. Let me just remind you if you've forgotten. Now remember that we talked about limit and we said if we have limit as h is approaching 0 of sine x over x, this is equal to 1, right? And also remember that we talk about limit as x is approaching 0, 1 minus cos s divided by x, this is also equal to 0. So this is what you are going to use to also evaluate this limit here. So we are going to manipulate this so that we get something like this out of it. So let's do that. Now the limit here can be written as this: limit h is approaching 0 sine x. Now here I can factor minus out because I need 1 minus cos, not cos minus 1. So when I factor minus out, this becomes minus here, and this will be 1 minus cos h divided by h, because I want to split this one from this, because I know that a plus b divided by c is the same as a over c plus b over c. So this will be plus then cos s sine h divided by h. Now there is something, this is happening here. You see that this here is the constant multiple rule, right? Because sine x does not depend on h, so it's constant, so I can factor it out. So I'm going to have minus sine x out, limits h is approaching 0, then I'm going to have 1 minus cos h divided by h. Then I put the limit on this one too, so I'm going to have plus. Now cos 2 does not depend on h, so I can bring it back. So cos x limit h is approaching 0 sine h divided by h. So what can you say about this? This is equal to 1 because this h is approaching 0, h, and you see that x is approaching 0, x is 1. So this one will be 1. This one, h is approaching 0, 1 minus cos h, x is approaching 0, 1 minus cos x divided by x is equal to 0. So this is going to give us minus sine x times 0 plus cos x times 1. This is going to be 0 plus cos s, and this is going to give us a big cos x. So that's the reason why when you say that when you differentiate sine, you get what? Cos. So f prime is of sine is cos. I'll give you one in the trial question where you are going to now differentiate cos and get negative sign. You go through the same process to pick up the idea. So I'll just do this last question here, and then I'll give you a trial question for you to also try, right? And then we are done. So let's go through this nice question, and then we are done with this video. Now here, the same idea, we want to use the limit definition to compute f prime, right? So this one is like the same thing like the radical function, but the first radical function that we did was in the form of, something like, not in the form of radical, like polynomial form. So we want to look at the one in the rational form. So let's do that. Same idea, define your limit formula here. H is approaching 0, f of x plus h, f of x divided by h. Now pick your f of x, which is 8 divided by square root of x minus 1. And as I said, if you are not good with doing substitution, you can put all your x in parentheses so that it will help you to find f of x plus h. So change all the 1 in the parentheses to x plus h, and this is going to give us this divided by square root of x plus h minus 1. So what do we need? We need this. So let's look for that. We need f of, write it here, we need f of x plus h minus f of x. F of x plus h is 8 divided by square root of x plus h minus 1 minus f of x is 8 divided by square root of x minus 1. So the question is, how am I going to do this? So basically, let's try and find, try to combine them together, and then we take it from there. So what you can do is we can find a conjugate for this, and then also find a conjugate for that, and then we just solve them. But what we need to do first is we can try to combine this to this, and then also solve it, and then see how we are going to get our things to be. So let's start. This is going to be something like this. This, that, this. So first, second, third, right? So let's go through. This is going to give us, this time this is going to be 8 square root of x minus 1. And then going this way is going to give us minus 8 square root of x plus 8 minus 1. And then going this way is multiplying this. We know that root of a times root of b is equal to root of a times b. So this is going to give us root of x minus 1 times x plus 8 minus 1. So this is what we are going to get at the end of the day. Now, getting this, what we just need to do here is now we need to try and find the conjugate so that we can, solve this. So now let's find the conjugate from this side so that we can go and cancel the h, because the h is what is important to us for us to cancel. So now let's find the conjugate. I'll just multiply this one by 8 square root of x minus 1 plus 8 square root of x plus 8 minus 1 divided by 8 square root of x minus 1 plus 8 square root of x plus 1 minus 1. So let's simplify this. Multiply this one by this. I'm going to have 8 times 8 is going to give us something like 64. Then square root will give us this minus another 64. Then the square root is going to give us x plus 8 minus 1 divided by, I will not simplify that down, I'll just multiply them because the one that we need to simplify is the one that we've done. So x plus 8 minus 1 then times 8 square root of x minus 1 plus 8 square root of x plus 8 minus 1. Good. So let me just still go down here. So the top, when I factor 64 out, it will be left with x minus 1 in the bracket here. And when I factor 64 out here, this one will be left with minus times everything here. So I'm going to have minus x minus 8 plus 1 divided by the whole of the denominator, the x minus h, x minus 1 times x plus 8 minus 1 times 8 x minus 1 plus 8 x plus 1 minus 1. So the top, the magic happens 1 and this and that. So the h now come and stand alone. So we have the h standing alone, which is 64 h divided by the whole of the one that we have, the x minus 1, x plus 8 minus 1, then all this times 8 square root of x minus 1 plus 8 x plus 8 minus 1. So this is what we have for the top, right? So we can just come and bring it here. So x limit s, h is approaching 0. So this is what we have here. Let me just copy it and just go and bring it to the top. So this is going to give us, let me paste it here. Good. It's kind of very big. So let me just bring it here. Let me put the limit on it here. Good. So this is what we have. This is what we have, right? This is what we have for the limit. So this is equal to this. But remember, the whole of this thing is this. So we need to divide it by h. So when I divide this one by h, this is the same as saying divided by h. And the divided by 8 we change to times 1 over h. So this is going to be times 1 over h. So that the h will cancel the h. So this is going to give us something like 64 divided by everything there. So let me just pick this guy and then paste it again. So now since I've cancelled the h will just go away. So now since the h which is causing the problem is gone, what we just need to do is set 8 to 0 and just plug it in. So 64 divided by square root of x minus 1, and then this one will be x plus 0 minus 1, right, times 8 square root of minus 1 plus 8 square root of x plus 0 minus 1. Good. So this is going to give us 64 divided by, here is going to give us x minus 1, and then times, down here is going to give us x square root of x minus 1 plus 8 square root of x minus 1. So something nice is coming up. This is going to give us 64 divided by, the down will be square root of x minus 1 squared times 8 out. So this is going to be 8 plus 8 is going to be 16 square root of x minus 1. This is 64 divided by this. Will cancel that. So this is going to give us x minus 1. And then we have 16 here. So let me put the 16 in front. And this is going to give us square root of x minus 1. Good. So maybe I think 16 goes to 64, right? Because I know that 8 goes here 8 and goes here 2. 2 goes here 1 and goes here 4. So it means that this is going to give us 4 divided by x minus 1 and square root of x minus 1. So this is what we are going to get at the end of the day. Now, what we just need to do is, the last question here is basically asking us to find f prime of 5. So we know that f prime of x is equal to 4 divided by x minus 1, then square root of x minus 1. So what are we going to get? This is going to give us f prime of 5 will be 4 divided by 5 minus 1, square root of 5 minus 1. And this is 4 divided by 4 times square root of 4. This is 4 divided by 4 times 2. And this is 1 over 2. So this is kind of like complicated, small, but take your time and then you'll be good with this. So I'll give you this one to try. I think I've given you everything that I did, which is fair. So please do this and leave your answer in the comment section. So this is a polynomial function. This is a rational function. This is a radical function. And this is a trig function. So do this and leave your answer in the comment section. Now, in the next video, guess what we are going to talk about? We are going to talk about properties of what? Derivative. And the properties of derivative, I've grouped them into 2. And I hope you are going to enjoy it. So see you in the next video.